In today's video, here are two following problems. One of the problems came from Indian Mathematical Olympiad. The second problem that was suggested by viewer. Okay, so here is the first one. We have x, y as a positive integers, such that we have this following inequality: x squared plus y cubed is superior to x cubed plus y to the fourth. So the question, we are going to prove this following inequality: x cubed plus y cubed is inferior to 2. Okay, if you feel you don't have enough information to prove this one, just start with the absurd proof by supposing this inequality is going in the other direction. Okay, then at some point you will find the impossible to have this inequality. Okay, so by the way of contradiction, suppose we don't have this inequality. Suppose we have x cubed plus y cubed is strictly superior than 2, because we have only two options. This inequality, it may go this way, it may go the other way. If this way doesn't work, which means it was going the other way. Okay, that's the idea we are going through now. I'm going to hold this one as it is. I'm moving on to the given information. The given information, so we have this following inequality: x squared plus y cubed is superior to x cubed plus y to the fourth. This one, I'm going to translate this one to another form. It was like this: it was x squared is superior to x cubed. The second one, it was y cubed is superior to y to the fourth. Okay, considering both numbers are positive. Okay, so if you sum this one, if you put this one on this one, is taking you back to this one. Since we have x and y as a positive integers, since we have x is strictly superior than 0 and y is strictly superior than 0, now we are allowed to divide both sides by x. If I'm going to do that by dividing both sides by x squared, so this one is giving us 1 is superior to x. This one follows similarly to this one. I will get 1 is superior to y, like this. Okay, so by flipping this inequality, x is inferior to 1 and y is inferior to 1. What does this mean? This means these both numbers are between 0 and 1. So which means x is between 1 and 0. We have strictly inferior than 0 like this, and y is between 0 and 1 as well. So I'm going to keep this one by using both inequalities. So I'm going to raise number 3 as a power on both sides. So we'll get x squared, x cubed is inferior to 1, and y squared, y cubed is inferior to 1. I'm going to sum these inequalities. I get here x cubed plus y cubed is inferior to 2. But the problem, we already assumed this one is strictly superior than 2. But we have x cubed plus y cubed is strictly superior than 2, which is a big contradiction. Okay, what we have contradicted, we have contradicted this one. Finally, x cubed plus y cubed is inferior to 2. Okay, now I have proven this one. Now let's move on to the second question. For the second problem, find the biggest prime p such that p divides this large term, which is 3 to the 12 plus number 4. Okay, so we are going to use here the factorization prime. Okay, if you have a product involving the prime numbers, which means you will have the product of the small prime numbers including the large prime. Okay, so among these products we are going to determine the biggest prime for this one. Okay, so I'm going to pick up this number. Let's call this big number as a q, equals 3 to the 12 plus number 4. So our question, we are going to determine p as a prime. Okay, let's put in this box. What I'm going to do now, I'm going to try to make the perfect square here by factorizing this one. So q equals 312 plus number 4. This one it can rewrite as 3 to the 6 quinary square plus 2 square, like this. But this one is an uncompleted square. We are going to complete this square by putting this one 3 to the 6 plus 2 quinary square. So if I'm going to distribute this one, is giving us 3 to the 12, which is 1, plus number 4, which is this one. But we have extra term here. We need to subtract that term. So we'll have minus 2 is multiplied by 2 is multiplied by 3 to the 6, which is 4, minus 4 is multiplied by 3 to the 6. So I will have q equals 3 to the 6 plus number 2 quinary square minus 2 to the 3 square. So I have transferred this one into this one. Okay. So also I have a difference of two squares. I'm going to factor this one on the form of the product. So I will have 3 to the 6 plus number 2 minus 2 is multiplied by 3 to the 3 factor 3 to the 6 plus number 2 is multiplied by 3 to the 3, like this. Okay. Now I have created a nice product here. Okay. This is going to be written on the form of the factorization prime, as I said before. Okay. So I'm simply going to simplify this expression by taking 3 to the 3 as a common factor. So I will have, by putting number 2 as a first term, I will get 2 plus 3 to the 3 factor. This one is going to be multiplied by 3 to the 3. This one is going to be multiplied by minus 2. Then I'm going to start with the second product. I will have number 2 here in the front plus 3 to the 3 factor 3 to the 3 plus number 2, like this. Okay. By simplifying this one out, I get 27 here. This one 27 minus 2, which is 25. The second product I will have 2. I will have the same thing, 27 is multiplied by 3 cubed, which is 27 plus 2, which is 29. Okay. Now I have this product, 27 is multiplied by 25. 27 is multiplied by 29. So if I'm going to calculate this one, is given as 677. This one is given as 785. Okay. So this 785 is the same as 5 is multiplied by 157. Okay. Now I will have a factorization prime of number 5 is multiplied by 157 is multiplied by 677, which equals P1 is multiplied by P2 is multiplied by P. This one that I have here. Okay. I get the smallest prime here, which is 5. I get the second prime, which is 157. I get the biggest prime, which is 677, which we were looking for. Okay. All of these are the prime numbers. Okay. All of these are divisible by this large number. Okay. So I found the biggest prime, which is 677. Okay. So I have done with problem. If you are interested in this one, don't forget to support us with a like and subscribe. Thank you for watching. I will see you next video. Bye.